Hello and welcome to this session. This session is all about Newton's law of cooling, one of the application of differential equation. So, let's start. When we say Newton's law of cooling, it is defined as the time rate of change in the temperature of a body, which is directly proportional to the difference in body temperature and the environment temperature. So let's say that you have du over dt, which is supposed to be the rate of change of your body temperature, wherein u is supposed to be your body temperature and the ue is your environment temperature. So let's formulate the equation. So the definition is your rate of change of body temperature, which is your du over dt, proportional to the difference of your body temperature, which is the u, and the environment temperature, which is the UE. So du over dt proportional to u minus ue. So to formulate the equation, you have to put k. So you will have du over dt equated to k of u minus ue, wherein k is our proportionality constant. So using your differential equation, we have the separation of variables. So isa-separate natin si u at si t kasi you have your du and you have your dt. So your variable there is u and t. So you will have du over u minus ue equated to k dt. Then we have to integrate both sides. You will have the integral of du over u minus ue equated to integral of k dt. Then you have plus c. Now, after you integrate that, you will now have ln of the quantity u minus ue equated to kt plus c. Now, para mawala si ln, you have to exponentiate both sides. You will have e raised to ln of u minus ue equated ngayon siya sa e raised to kt plus c. Now, this side, pwede natin tong paghiwalayin. You will now have e raised to kt multiply to e raised to c. Then this side, makakancel na ngayon si e raised to ln. Ang matitira na lang is u minus ue. Then, taking note that e raised to c is considered as our arbitrary constant. So, pwede siyang i-simplify as c. Then, itatranspose natin si ue sa kabila para ma-isolate natin si u. So, you will have u equals ue plus c e raised to kt, wherein your u is your present body temperature, then ue is the environment temperature, c is your arbitrary constant, then t is the time, and k is the rate of change of your body temperature. Now, if you're going to ask if you have constant environment temperature, yes, you will have your constant environment temperature, meaning to say, hanggat hindi ka lumilipat ng venue or place, it is considered as constant temperature. So for you to understand the whole topic, we'll have to go to the examples. Okay, example number 1. Let's say you have a thermometer reading of 18 degrees Fahrenheit brought into a room where the temperature is 70 degrees Fahrenheit. 1 minute later, the thermometer reading is 31 degrees Fahrenheit. Now, you'll have to determine the temperature reading as a function of time and in particular. Then you'll have to find also the thermometer reading 5 minutes after the thermometer is first brought into the room. So in table, you will have the time, you will have the U, wherein that is your body temperature, and you will have your UE, wherein that is your environment temperature. So you will notice that UE is constant since hindi naman tayo lumipat ng venue or place. So you will have 70 degrees Fahrenheit as your environment temperature. Then at zero time, you will have your initial thermometer reading, which is 18 degrees Fahrenheit. Then the problem says that after 1 minute, the reading is 31 degrees Fahrenheit. So you'll have to determine the reading as a function of time. So ibig sabihin, equation yung hinahanap natin dun sa letter A. Then sa letter B, you have to find the exact amount of the thermometer or the exact reading of the thermometer after 5 minutes. So let's do the solution. For the solution, you have your formula U equals UE plus CE raised to KT. Then, following your condition number 1, at 0 time, your U is 18 degrees Fahrenheit, your UE is 70 degrees Fahrenheit. Then, substitute natin siya dun sa formula. You will now have 18 equals 70 plus C e raised to K of 0. So you will now have e raised to 0 is 1. So matitira dito is c. Then transposing 70 to the other side, you will have 18 minus 70 equated to c. Therefore, the value of your c is negative 52. Now, for the condition number 2, you will use the computed value of c. Since meron na tayong value ni c, yun ngayon yung gagamitin nating c dun sa whole problem. So for the condition number 2, at time is 1 minute, your U is 31 degrees Fahrenheit, and your UE is the same as 70 degrees Fahrenheit. Then substituting that dun sa formula, you will now have 31 equals 70 minus 52 e raised to k of 1. You will now have to find the value of k. So transposing 70 to the other side, you will have 31 minus 70 equated to negative 52 e raised to k. Then dividing the whole equation by negative 52, you will have negative 39 over negative 52 equals e raised to k. Then taking the ln of both sides, you will have ln of e raised to k equated to ln of 39 over 52. Since the property of natural logarithm, if you have ln of e raised to k, ang matitira na lang dito is k. So you will have k equated to ln of 39 over 52, or approximately equal to negative 0.2877. Since you have the k and you have the c, you can now have your temperature reading as a function of time. So this is an equation in terms of time. So any time t, your body temperature can be computed through 70 minus 52 e raised to negative 0.2877 t. So that's your answer for letter A. Now let's go for letter B, wherein you will have to find the thermometer reading after 5 minutes. So you will have T equals 5, U is unknown, UE is 70 degrees Fahrenheit as the same. So you will have to substitute yung values dun sa equation mo kay A. You have 70 minus 52 of e raised to ln of 39 over 52, that is your k, multiplied by the time t, or with time of 5. So you will have the value of u as 57.66 degrees Fahrenheit, or approximately equal to 58 degrees Fahrenheit. So after 5 minutes, when you first brought the thermometer into a room, the reading will be 57.66 degrees Fahrenheit, or approximately equal to 58 degrees Fahrenheit. Now let's go to the next example, example number 2. You have a thermometer reading of 75 degrees Fahrenheit is taken out where the temperature is 20 degrees Fahrenheit. The reading is 30 degrees Fahrenheit 4 minutes later. So you'll have to find the thermometer reading 7 minutes after the thermometer was brought outside. Then the time taken for the reading to drop from 75 degrees Fahrenheit to within a half degree of the environment temperature. So for the table analysis, you will have the time from the starting time, which is 0, then after 4 minutes, then after 7 minutes, and then unknown time yung kay letter B. So sa 0 time, your initial value is 75 degrees Fahrenheit. Then after 4 minutes, your reading is 30 degrees Fahrenheit. Then for the letter A, after 7 minutes, you'll have to find the degrees. Then for the letter B, then the unknown time, we're in from 75, which is your initial, magdadrop siya to within a half degree of the environment temperature. So within a half, so ibig sabihin 0.5 degrees yung difference niya dun sa environment temperature. Since our environment temperature is 20 degrees Fahrenheit, so the reading for the unknown time is 20.5 degrees Fahrenheit. Since isa lang yung place na dinalan nung thermometer, so you'll have one environment temperature which is 20 degrees Fahrenheit. So let's go to the solution of the problem. For the solution, you'll have the same formula, U equals UE plus C e raised to KT. Now, for the condition number 1, you'll have time is equal to 0. U is 75 degrees Fahrenheit. UE is equal to 20 degrees Fahrenheit. Now, substituting all the values dun sa formula, you will have 75 equals 20 plus C e raised to K of 0. E raised to K of 0, that is E raised to 0, which is equivalent to 1. So, C na lang yung value na to. Then transposing 20 to the other side, you will have 75 minus 20 equated to C. Therefore, your C is 55, and that is your computed value of C, which you will be used to the other conditions. Now, for condition number 2, you have time of 4, U of 30 degrees Fahrenheit, UE is equal to 20 degrees Fahrenheit. Now, substituting the value of C, or the computed value of C at the condition 1, then all the values given at the condition 2, you will now have 30 equals 20 plus 55 multiplied to E raised to K, wherein the time is 4. So, computing for the value of K, transposing 20 to the other side, you will have 30 minus 20 equals 55 E raised to 4K. Dividing the whole equation or both sides into 55, you will now have 10 over 55 equated to E raised to 4K. Now, taking the ln of the both sides, you will now have ln of E raised to 4K equated to ln of 10 over 55. Now, makakancel po ngayon si ln E. You will now have 4K equated to ln of 10 over 55. Now, dividing both sides by 4, the value of your K now is 1 over 4 ln of 10 over 55. Now, you have the value of K and you have the value of C. Pwede na nating makompute yung body temperature or the thermometer reading after 7 minutes. So for the condition 3, you will now have 7 and then U is the unknown value. Then U is still the same as 20 degrees Fahrenheit. So substituting that to the equation, you will have U equals 20 plus 55, which is your C. E raised to 1/4 ln of 10 over 55, which is your K, multiplied to 7, which is your time. Then the value of your U is 22.78 degrees Fahrenheit, or approximately equal to 23 degrees Fahrenheit. So that is the reading after 7 minutes mong dinala outside. Now, for the time taken, wherein the reading is 20.5 degrees Fahrenheit. For the condition 4, the time is unknown. U is 20.5 degrees Fahrenheit. UE is 20 degrees Fahrenheit. You'll have to use the same K and the same C. So you will have 20.5 equals 20 plus 55 e raised to 1/4 ln of 10 over 55 multiplied to T. Now, simplifying this equation, you will now have 0.5 over 55. 0.5 is from 20.5 minus 20. So you will have 0.5. Then divided by divided by 55. So you will have 0.5 over 55. Then, ang matitira na lang sa kabila is e raised to 1/4 of ln 10 over 55 multiplied to t. So you will have to take the ln of both sides. You will have ln of e raised to 1/4 ln of 10 over 55 multiplied to t equated to ln of 0.5 over 55. Then after that, you have to divide the whole equation or the both side by 1/4 ln of 10 over 55 since that is the coefficient na kasama ni t. Kasi nga makakancel na natin si ln e. So you will have to take t as equal to ln of 0.5 over 55 over 1/4 of ln of 10 over 55. So the time taken wherein the reading of your thermometer is 20.5, you will now have 11.03 minutes. So meaning to say after 11.03 minutes, your thermometer reading will drop into 20.5 degrees Fahrenheit. Now let's go to the next example, which is example number 3. You will have a thermometer having a reading of 100 degrees Fahrenheit is taken into a room having a constant temperature of 77 degrees Fahrenheit. The reading became 95 degrees Fahrenheit after 5 minutes. Now you'll have to determine 3 items. The first item is the temperature reading at any time. Now letter B, which is the second item, the thermometer reading after 15 minutes when the thermometer was brought inside the room. Then the third item is the temperature reading after a long period of time. So let's go to the the table analysis. So the starting time is 0, which is your initial temperature is 100 degrees Fahrenheit. After 5 minutes, the reading is 95 degrees Fahrenheit. And you'll have to find the reading after 15 minutes. Then you'll have also to find the reading after a long period of time or kapag nagstay na siya ng matagal dun sa room. Then you have the constant temperature of 77 degrees Fahrenheit. So let's go to the solution of this example. So for the solution, you have the same formula again. You will have U equals UE plus CE raised to KT. Now, considering your first condition wherein the time is 0, your U is 100 degrees Fahrenheit, your UE is 77 degrees Fahrenheit. Now, substituting these values dun kay formula, you will now have 100 equals 77 plus C e raised to K of 0. Since e raised to K of 0 is e raised to 0, which is also equivalent to 1, then you will have 100 minus 77 equated to C. Therefore, the value of C is 23. Now, you will use the computed value of C to the other conditions. Let's say you have your second condition, which is T equals 5. Your U is 95 degrees Fahrenheit, then your UE is 77 degrees Fahrenheit. Then you will have 95, which is your U, equated to 77, which is your UE, plus 23, which is your C. Then e raised to K multiplied to 5, which is your T. Then computing the value of K by simplifying this equation, you will have 95 minus 77 equated to 23 e raised to 5K. Then dividing both sides by 23, you will now have 18 over 23 equated to e raised to 5K. Then, taking the ln of both sides, you will now have ln of e raised to 5k equated now to ln of 18 over 23. Since you will have ln of e, ang matitira na lang is the exponent of e. You will have 5k equals ln of 18 over 23. Now, dividing both sides by 5, you will now have the value of your k as 1 over 5 ln of 18 over 23, which is approximately equal to negative 0.04902. Since you have the value of your k and you have the value of your c, you may now formulate the equation of your u at any time t. So that is your u of t equated to 77 plus 23 of e raised to negative 0.04902 multiplied to t. So this is your general formula, or the specific formula of your body temperature at any time t. Now, finding the reading after 15 minutes, you may use this formula. So you will have, after 15 minutes, you have the unknown u, and you have the same environment temperature, which is 77 degrees Fahrenheit. Then substituting these values to your equation, you will now have u equals 77 plus 23 e raised to 1/5 ln of 18 over 23 multiplied to 15. Therefore, the value of your u is 88 degrees Fahrenheit after 15 minutes. Now, for the condition number 4, you'll have to find the reading at a very long time, or no specific time, wherein kung kailan nagstay na siya ng matagal dun sa room. So, t is infinite, then u is the unknown, ue is the same as 77 degrees Fahrenheit. Now, substituting that values, you will now have u of equal to 77 plus 23 e raised to 1 over 5 ln of 18 over 23 multiplied to infinity. This value is supposedly negative 0.04902. So 0.04902 multiplied to infinity is the same as infinity, then multiplied to negative, so that is negative infinity. So you will have u equals 77 plus 23 e raised to negative infinity. We all know that e raised to negative infinity is equal to 0. So if you multiply 0 to 23, that is still 0. So your u, after a very long time, wherein the time is infinite, you will have 77 degrees Fahrenheit. So for the final answer for C, that is 77 degrees Fahrenheit. Now you will notice that your body temperature will be equal to the environment temperature after a very long time. So ibig sabihin, hindi siya lalagpas dun sa environment temperature. Let's say kung mainit yung environment temperature mo, hindi pwedeng mas mainit ka pa kesa dun sa environment temperature mo. Or kung malamig yung environment temperature mo, hindi pwedeng mas malamig ka pa dun sa environment temperature mo. Meaning to say, pwedeng maging equal pero hindi pwedeng lumagpas. Next example, example number 4. Example number 4 says that using Newton's law of cooling, how long will it take to cool 100 degrees to 55 degrees? If the air temperature is 25 degrees and the substance cools from 100 to 65 degrees in 15 minutes. So in table analysis, you have 0 as your initial time, wherein your initial temperature is 100 degrees. Then after 15 minutes, the reading is 65 degrees. You have constant temperature of 25 degrees. Now you'll have to find the time when the reading would be 55 degrees. So for the solution, you will have u equals ue plus c e raised to kt. Now following your condition number 1, at 0, you have 100 degrees and you have 25 degrees for the environment temperature. Substituting that values dun sa formula, you will now have 100 equals 25 plus c e raised to k of 0. So 100 minus 25 is equal to c. Therefore, your c is 75. So for condition number 2, you'll have the time taken, which is 15 minutes. Then for your u, which is 65 degrees, and then your ue is 25 degrees. So you will have 65 equals 25 plus 75, which is the computed value of c, then e raised to k multiplied to 15. Then you will have 65 minus 25 equated to 75 multiplied to e raised to 15k. Then dividing both sides by 75, you will now have 40 over 75 equated to e raised to 15k. Now, taking the ln of both sides, you will now have ln of e raised to 15k equals ln of 40 over 75. So that would be equal to 15k equated to ln of 40 over 75. Dividing both sides by 15, therefore the value of your k is 1 over 15 ln of 40 over 75, which is approximately equal to negative 0.0419. Since you have the value of k and you have the value of c, you may use that values dun kay condition number 3, wherein the time is unknown, the u is 55 degrees, then your u is the same as 25 degrees. So substituting all the values, you will have 55 equals 25 plus 75 e raised to 1 over 15 ln of 40 over 75 multiplied by t. This time, your unknown is the time. So you will now have to simplify this equation. You will have 55 minus 25 equals 75 e raised to 1 over 15 ln of 40 over 75 multiplied to t. Then, dividing both sides by 75, you will have 30 over 75 equated to e raised to 1 over 15 ln of 40 over 75 multiplied to t. Then taking the ln of both sides, you will have ln of e raised to 1 over 15 ln of 40 over 75 multiplied to t equated to ln of 30 over 75. Now simplifying this equation, you will now get 1 over 15 ln of 40 over 75 multiplied to t equated now to ln of 30 over 75. Dividing both sides by the coefficient na kasama ni t, you will now have to find t is equated to ln of 30 over 75 all over 1 over 15 ln of 40 over 75. Therefore, the value of your t is 21.86 minutes or approximately equal to 22 minutes. Meaning to say after 22 minutes, the reading from 100 degrees will drop into 55 degrees. Now let's go to the last example of this session. Example number 5. At 1 p.m., a thermometer reading is 70 degrees Fahrenheit, which is taken outside where the air temperature is negative 10 degrees Fahrenheit or 10 below zero. So at 1:02, the reading is 26 degrees Fahrenheit. At 1:05, the thermometer is taken back indoors where the air temperature is 70 degrees Fahrenheit. What is the thermometer reading at 1:09? So meaning to say, if you analyze this problem, you have two venues. One is outside or outdoor. The second one is inside or what we call the indoor. So you'll have to analyze the two scenarios. So let's say you have the outdoor condition at 1 p.m. which is your base time, so that is 0. The reading is 70 degrees Fahrenheit. Then at 1:02, that is after 2 minutes, your reading became 26 degrees Fahrenheit. So at 1:05, that is 5 minutes, after 5 minutes, you don't have the reading. So yun yung magiging basis natin bago mo siya ipasok ulit sa loob. Kasi itong condition na to, this is outdoor condition wherein the air temperature is negative 10 degrees Fahrenheit. So you have to find first yung reading niya at 1:05 p.m. bago mo siya ibalik sa indoor condition. So, pag dinala mo siya sa indoor condition, kung ano yung magiging reading niya at 1:05, syempre, yun din yung reading niya bago mo siya ipasok sa loob. So, the base time is 1:05. Since this is another venue or another condition, you will now have base time na 1:05. So, magsimula ulit tayo sa umpisa na 0 time. But the environment temperature is 70 degrees Fahrenheit. Now, the question is, you'll have to find the reading at 1:09 p.m. after 4 minutes na dinala mo siya sa loob. Bakit 4 minutes lang? Kasi your base time is 1:05. So, you will have to find the reading at 1:09. There's only 4 minutes difference between the times. So, yung 1:09 p.m. mo is just 4 minutes after you brought the thermometer inside. Taking note that if the environment has been changed or kapag nagbago ka ng venue, you will have to consider this 3. time will be reset and back to 0 since it will have new base time. So ito yung sinasabi ko kanina, nagkaroon ka ng bagong base time kasi dinala mo siya sa ibang venue or the environment temperature has been changed. Next is value of C will be changed. So iba yung value ni C kay outdoor at iba din yung value ni C kay indoor. But the computed K will be always the same. So kung nakapag-compute ka na ng K kay outdoor condition, yun na din yung gagamitin natin K kay indoor condition. So ang mababago lang na values is the C, pero yung K will stay the same. Tapos, yung time will be back into 0 kasi nagkaroon ka ng bagong venue. So let's go to the solution. First, we have the outdoor condition. You have the formula, the same formula pa din, U is equal to UE plus CE raised to KT. For the first condition at the outdoor condition, you will have base of 0 time, U is 70 degrees Fahrenheit, UE is negative 10 degrees Fahrenheit. So you will have 70 equated to negative 10 plus C e raised to K of 0. So your C is now 70 plus 10, therefore your C is 80. So that is your computed value of C. Now for the condition 2, you will have T is equal to 2. So that is after 2 minutes. The reading will be 26 degrees Fahrenheit with the same environment temperature, which is negative 10 degrees Fahrenheit. So substituting all the values dun sa formula, kasama na yung computed value ni C, you will now have 26 equals negative 10 plus 80 e raised to K of 2. Now you will have to find the value of K in that formula or in that equation. So you will have 26 plus 10 equated to 80 e raised to 2K. Dividing both side by 80, you will now have 36 over 80 equated to e raised to 2k. Now taking the ln of both sides, you will now have ln of e raised to 2k equated to ln of 36 over 80. So since you have the ln of e, matitira na lang yung exponent ni e, so you will have 2k equated to ln of 36 over 80. Dividing both sides by 2, you will now have k of 1/2 ln of 36 over 80. So ito yung gagamitin natin K even in the indoor condition. So itong C na to, which is the computed value of C, at the outdoor condition, it will be stay at the outdoor condition. So hindi natin pwedeng gamitin yung C na to kay indoor condition. Pero yung si K, pwede natin gamitin to kay indoor condition. Now, continuing to the condition number 3, which is T is equal to 5, then your U value, which is our A, you will now have UE is the same as negative 10 degrees Fahrenheit. So you'll have to find the value of A. So following the formula, that is A equals negative 10 plus 80 e raised to 1/2 ln of 36 multiplied by 5. So the value of your A is 0.8673 degrees Fahrenheit. So ito ngayon yung ipapasok mong values sa indoor since ito yung reading mo at 105. So let's go to the indoor condition. So at 1:05 p.m. condition, you will have this the new base time, which is time is equal to 0. So our U is equal to A, which is the computed A at 1:05 at outdoor condition. So bago na ngayon yung environment temperature mo, which is 70 degrees Fahrenheit. So since nagbago yung environment temperature mo, mababago ngayon yung computed value ni C. So yun yung una nating hahanapin, which is the value of the C. So you will have 0.8673, which is the value of your A, equated to the new environment temperature, which is 70, plus C e raised to the original value of K, which is 1/2 ln of 36 over 80, multiplied to 0, which is your base time. So the value of your C is 0.8673 minus 70. So that is equivalent to negative 69.132. Since you have the new value of C and you have the computed K at outdoor wherein you can use that indoor condition. So, pwede na nating mahanap yung reading ni U at 1:09 p.m. So, let's say you will have T is equal to 4, U is unknown, then UE is 70 degrees Fahrenheit since that is the indoor condition. So, you will have U equals 70 minus 69.132 e raised to 1 half ln of 36 over 80 multiplied to 4. So, that is 56 degrees Fahrenheit if you input it in calculator. So, after 4 minutes na dinala mo siya sa indoor, you will have the reading of 56 degrees Fahrenheit. So, that's it for this session. That is all about Newton's law of cooling. And I hope you learned a lot for this session. If you have any questions, just comment down your question or just PM me on my messenger. Thank you and God bless.